Good evening. Welcome to the first in a new series of free online evening seminars organised by SGAI, the British Computer Society Specialist Group on Artificial Intelligence. We're starting this series with a seminar on, well, it couldn't really be a much more topical subject, which is large language models, including ChatGPT. This seems to have been continually in the news, newspapers, popular press, television, radio, everywhere in the last few weeks. Is this a major technical breakthrough, or is this an existential threat to humanity, or is it possibly both? Well, maybe we're going to find out this evening. At least I hope so. We'll find out a lot more than we know already at the moment. This evening's seminar is chaired by Professor Adrian Hopgood from the University of Portsmouth, who I'm very pleased to welcome here. So over to you, Adrian.
Thank you very much, Max, and good evening, everyone. First of all, a bit of housekeeping. Could I ask, if you're not speaking, that you mute your microphones, please, just to cut down on any echo or background noise. So it's a great pleasure to welcome you to tonight's event, Large Language Models, including ChatGPT and BERT. We've got two excellent speakers providing a nice balance of both academic and industrial perspectives. Our first speaker this evening will be Dr. Mercedes Arguello Casteleiro from the University of Southampton. And our other speaker is Andrew Lee, who's head of AI at PersuasionXP. He's also a fellow of the BCS and the RSA. And I should say that both of our speakers are committee members for the BCS Specialist Group on AI. You should be able to see on your screen at the moment the schedule for this evening, and you'll see that they are alternating in their presentations, each having 2 slots of 20 minutes each, and that is intended to include some questions. So 5 minutes of questions.
Das muss nicht sein. Ja, was ist passiert oder was?
Yeah, if I could ask all participants to mute themselves, please, if you're not speaking. Thank you very much. Don't seem to have the power to mute myself. Okay, so without further ado, I think that's covered everything, and I'll hand over to our first speaker, Mercedes, who's going to set the scene with a general introduction to large language models, what they are, and how they work. Over to you, Mercedes.
Thank you very much, Adrian. So I'm going to share my screen. Can someone, Adrian, can someone confirm that you can see my screen?
Yep, that's all good.
Okay, thank you very much. So as Adrian mentioned, this talk is divided into 2 parts. In the first part, we're going to do an introduction. We're going to investigate what are large language models and how do they work. So first, we need to consider that there is deep learning that is part of machine learning, and machine learning is part of artificial intelligence. As some of you are aware, deep learning is providing new learning algorithms and architecture, and the use of modern neural nets is often called deep learning because these networks are often deep. This means that they have many layers. If you are interested in the topic and you say, give me a paper that is the more foundational paper for deep learning, I would suggest this one. However, this paper was published a few years ago, and they say very clear that natural language understanding is another area in which deep learning is poised to make a large impact over the next few years. You may question yourself why natural language understanding is so hard. So it's hard because a word like jaguar can have multiple meanings. The real power of deep learning comes from the ability to learn features from data. And instead of building the features or selecting the features manually, we do it automatically. and one of the major breakthroughs, it was to learn the representation of words through embeddings. Just to remind you, when you represent a word with a real value vector, this is an embedding representation. So embeddings are vectors representing words. When you look at the state of the art of neural language models, the most powerful are based on transformers, and they're far more complex than the simple feed-forward language models, although the bases are there. So in this case, you can see 3 words: dead, desert, is, and in a very simplified way, what we try to do is binary classification, is sentiment classification. One of the tasks that you need to keep in mind for even simple feed-forward neural language models is to predict the next word given some prior words. So you have 3 words, for example, for, all, the, and you're trying to guess which will be the next word. BERT is undeniably, or was undeniably, quite a big breakthrough, and you can do some basic understanding of the test by doing questioning and answering, and I will come back to you with the programmatic details in order how to use BERT with a few lines of code in order to do questioning and answering. And another thing that we're going to cover on this talk is the fine-tuning of large language models. You will see in a moment that typically large language models are pre-trained on a large corpus, and then you train them, you fine-tune them for a specific task. If you question, or if you are curious why they are called explicitly large, well, they are large because in the case of BERT, it has 110 million parameters. BERT large has 340 million parameters. And at the time that it was published BERT base, the model has the same size as OpenAI GPT. Some of you might or might not be aware of what is happening right now. So for example, Microsoft and NVIDIA, they're working together in something that is called Megatron Turing. And the number of parameters is 530 billion. Of course, there is the question of, even if the model is bigger, will this mean that it's doing better, that it can do more useful things for the end user? That's another question that we are trying to answer, to investigate. Just coming back one more time about this Megatron Turing with these 530 billion parameters. You can see here the different data sets that was used for training, and it was trained with 339 billion tokens. And you can see that different data sets they were considered. Now, one of the things that perhaps is more on the news, or why is making such a discussion in the artificial intelligence community. In 1950, Alan Turing wrote a paper and it questioned if can machines think? And he envisioned a test that basically the computer the algorithm should look somehow human, in the sense that a judge is unable to distinguish between the human and the computer. So ever since the question of Alan Turing about can machines think, there has been this emerging of different chatbots. And of course, as technologically progress, they are more and more sophisticated. Let's have a look to those. In the Alan Turing test, you will have the human interrogator, and you will have a human, and you have a computer. And the interrogator is posing questions to both. And supposedly, if for 5 minutes, the computer is answering the question in such a way that it resembles a human, it will pass the Turing test. One of the first programs that I tried to pass the Turing test, it was ELIZA. This is 1966. And you can see here that a user says something that I'm unhappy. And what is the reply from ELIZA? And you can keep going with the conversation. Even at the time, it was questioning that ELIZA and even its modern descendants, if it is just mere tricks. If some of you are curious and wanted to have a look to this old technology, I invite you to have a look to these 2 links. And through these 2 links, you can interact with an online version of ELIZA. Similarly to what you know about ChatGPT, even if you pose the same question, perhaps you will obtain different replies. Another interesting thing, even for this very old program, is if you don't reply for a few minutes, ELIZA will come back to you with this, are we going to chat? I can help you without a dialogue. If some of you are really, really interested, at the bottom, you will have the link with the original paper for ELIZA and the original code, and you realize that it was just 3 pages of code. So it's quite impressive what it can do, just 3 pages of code. Now, in more modern times, perhaps you can hear about Google Lambda and also, of course, ChatGPT. And there is this ongoing discussion if they pass the test of Turing, in the sense that if a human interrogator is interacting with Google's Lambda or OpenAI ChatGPT for 5 minutes, it may give the impression that it's a human. So it will pass the test of Turing. This, I leave it to you. One thing that you may notice is the amount of parameters, which is Lambda will had 137 billion parameters, and ChatGPT 175 billion parameters. Some of you may or may not know about this conversation, which was quite famous, where Moyle asked explicitly to Lambda about ELIZA and what was the opinion that Lambda has about ELIZA. And for this script of the conversation, yes, you may get the sense that perhaps, you know, there is something clever happening here, some trickery or something that it may resemble the reply of a person. If you wanted to have a look or a crude comparison between Lambda and ChatGPT, Lambda can predict a missing word from the test. So a win is for producing, and then there will be the missing word. So in this case, Lambda may reply, oh, that's easy. You use the word lift. As some of you know, ChatGPT is quite famous because it can reply to a wide range of prompts using different styles and degrees of sophistication. If we do a very crude comparison between ELIZA and ChatGPT, the latest version, which is the 3rd of May version, if we ask ELIZA, I'm unhappy, this is the typical reply that we saw before. ChatGPT, as you can observe here, it will reply in a more elaborate way. And that's why perhaps the current discussion that is triggering doubts if ChatGPT passed Turing test or not. If we have, or if we pose a more intriguing question, which is, do you have consciousness? Eliza replies, but it replies in a very crude, brief way. We were discussing you, not me, but we still have a reply. And remember, Eliza is just 3 pages of code. Of course, ChatGPT, we have something more elaborated, something more sophisticated, although in a nutshell, the answer is I do not possess awareness or consciousness. Another thing for you to consider perhaps is, and this I'm going to show you in part 3 how to do it programmatically, so you will be able to interact not only through the graphical interface available, but also doing this in a programmatic way, is if we ask ChatGPT, the version of the latest version, the 3rd of May version, does cough belong to clinical presentation symptoms for COVID? Again, we have a very elaborate answer that resembles the answer of a human. However, we may question, like, how do I know that the information is not fabricated? Some people go beyond the obvious and started to even investigate if ChatGPT can pass medical tests. Like if we expose ChatGPT to different questions from clinicians using even 4 data sets, what will happen? So in this case, in the paper that was published, you will see that you will have accuracies of 44, 42, 64, and 57%. So maybe one of the things that we need to consider is what this accuracy means. The authors defend that is quite interested. It may perform similarly to a medical student, perhaps early years, very young medical student. However, for some of you that perhaps are aware of accuracies and you work perhaps on a related field, we know that normally 50% accuracy is equivalent to the flip of a coin. So what I'm trying to open to you is, are these results good? So some of you may interpret that they are not necessarily good because some of them are even below the 50% accuracy, which is less reliable than flipping a coin. Some people may say that this accuracy is inherently low because ChatGPT was not trained specifically in order to reply medical questions. However, the discussion is still there. Like when we have an answer from ChatGPT, can we rely on the answer provided? Is trustworthy? If we interact with ChatGPT for 5 minutes, do we have the sense that we are talking with a person? If we have the sense that we are talking with a person, perhaps you can argue that it passed Turing test. So this is part of the discussions, and I just was trying to provide you with a bit of data or a bit of numbers, and I leave to all of you the further interpretation of this. In part 3, I will try to teach you how you can interact with all these different large language models programmatically, how you, with very few lines of code, can you do certain tasks with them, and also how to fine-tune BERT, for example, for sentiment analysis. But this will be on part 3. So I'm going to stop here because I'm quite interested in your questions or your thoughts, and I will open for any questions or any remarks that you can have. So I'm passing back to the chairman in order to manage the questions. Thank you.
Thank you very much, Mercedes. That's great and really set up the evening nicely for us. We have one question's been posed by Mike Lloyd in the chat, and he's saying this is in relation to your last point about some of those ChatGPTs getting scores close to 50%, where you argue that 50% is equivalent to tossing a coin. So he's saying, but are the exams binary multiple choice? In other words, a yes/no choice. Or could you comment on that, please?
Yes, it's multiple choice.
But are there more choices than two?
Yes, some of the questions are multiple choice. I mean, these are examinations from the states, and it's as real as it gets. I mean, they try to test it with different set of questions. That is the same questions that clinicians in the states need to pass in order to get their certificates.
Maybe I'd like to ask Mike to open his mic to follow up on that.
Yeah, I mean, it's if you want to base it on flipping coins, then they have to be binary multiple choice questions. I dare say you can have a lot of them, and those questions could be quite sophisticated. But if you're going to compare, you know, the model to flipping coins, and you know, I just think you need to have a fair basis on which that comparison is made.
Okay.
I mean, thanks for your comments. As I say, what I'm trying to open the discussion is, if you go to a junior doctor and he says that he passes his exams 46% or 53%, would you prefer a doctor that perhaps achieve 89 or 92%? I mean, this is perhaps the typical bias that even ourselves have. Like, maybe the score that you get in an exam is not representative, or it does not reflect exactly the knowledge you may have. But again, I'm just bringing these papers not in order to have the ultimate answer, but mostly to question ourselves. Is this good enough? We also have to know or to acknowledge that these models were not even trained specifically in order to reply or to master the answering of medical tests. So that's another thing that is a bit unfair, that you use these models for a task that perhaps it was not even specifically considered. But the question remains, if we are going to question the good and bad or the limitations, maybe this is a way in order to have a look to some studies, some numbers that have been provided, and have a discussion about, is this good enough? Should we train them specifically, or what are our thoughts? So I do appreciate your comments.
Okay, thank you very much, Mercedes. Let's move on to a different question. Nico Attridge, if indeed that is the proper pronunciation of Nico's name, says, will the capability of large language models increase linearly with more data and larger number of parameters? Are you able to comment on that, please, Mercedes? I can't hear you, Mercedes.
Sorry. This is an excellent question, and it's exactly what is being investigated this minute with this new model from NVIDIA and Microsoft, because the number of parameters is substantively bigger, because the amount of data for the training, it was very, very large and substantive. It's going to perform better? Is going to provide more useful answers? This is still a question. And perhaps in time, or in the next forthcoming months, we will see some kind of plots or charts in order to see if, as you were mentioned, if it is linear or not, or what is happening here. So thanks for the question.
Okay, thank you. There's another comment that picks up the earlier discussion about the medical exams, and we take the point from Peter about negative marking, but let's maybe move on from that particular task, particular question. Rick Payne's asked a question. Actually, rather than me read it, maybe Rick would like to articulate your question, please.
Sure. Yeah, so in terms of how the ChatGPT in particular was trained, my understanding was there's sort of 3 elements to that. The sort of transformer model, which I won't claim to fully understand, some comparison to human chats, and also reinforcement learning, partly about removing sort of certain things you wouldn't want ChatGPT to say. So I just wondered if you could explain a bit more about how that fits together, and also how you see training changing in the future. Will there be new methods improve these models rather than just adding more and more parameters?
Yes, thank you for the question. So perhaps one of the things that I would like to do is, there is a paper that comments exactly about GPT-3 and how it was trained. So we know that they say that there was about 40 different experts, but there were many different subtasks or components. One of them is even, you know, in the wording that it just captured my eye, which is hallucination. So I will ask the organizer of the event. I mean, it's on the slides. I will mention to you, but there is a paper published, it's about 21 pages, that try to describe exactly how GPT-3 was trained in terms of the number of people, also the corpora, the data, and also, you know, the different tasks. And that could be a more thorough reply to your question. So thank you. I'll make sure that this information will be available after this event.
Okay, thank you. Another question has popped in. Maybe we'll park that one, if Olu, who's asked a further question about in relation to the Turing test. I think we're probably a good time to move on now, and but I'll bear in mind Olu's question for later. I think at this point, I'd like to thank Mercedes for her first part, and I know we've got her coming back again shortly, and now invite Andrew Lee to present intelligence and language knowledge models. And I believe Andrew's also going to include a demonstration. Over to you, Andrew, please.
Yes, thank you very much, Adrian. I'm just going to share a presentation which necessarily involves a bit of twitting around on desktops to get them to work. So there we go. Right, off we go. Adrian, can you just confirm that you can see the presentation there, please?
Yeah, all good. Thanks, Andrew.
Excellent. Thank you very much. So that's what I'm going to talk about. Adrian's given a very brief introduction to me. So I'm coming from a different background. I really come from industry rather than academia, and I've been working on this sort of stuff for many years. I've got other similar interests, one of which makes me observe that, of course, this is all about generating text, but there's also the other half of the world about actually understanding what's going on. Anyway, let's crack on. So intelligence and language knowledge models. So I'm going to focus a bit on kind of the knowledge representation that's going on with these systems. So by way of my introduction, I like to think of AI as existing in 3 levels. So the top one is really machine sentience. So this would be kind of the AI that we see in films, you know, self-aware, sentient, things with ethics and emotions and humor. And I think quite often when we say, is a system passing the Turing test, what we're really saying is it up at that level? But of course, actually, the level that nearly everything is about now is a slightly lower level, what you might call applied artificial intelligence, which are effectively obviously algorithms or heuristics which are inspired by models of intelligence. And indeed, of course, all these artificial neural nets are themselves a model of an idealized model of the sorts of things that is thought to be going on within the brain. And I would say that a working definition of this is the acquisition, manipulation, and exploitation of knowledge. So it all does come down to what a system knows and what it can acquire and what it can then do with that. And there's a particular characteristic of AI, I think. It's frequently, is it not, non-deterministic. So it adapts to new circumstances and it learns. This, of course, causes enormous problems when regulators try to say AI has got to pass these tests or must achieve this or that, because, of course, by its very nature being non-deterministic, it's quite hard in advance to say exactly what it must do, especially when one of the things that we hope AI will do, including large language models, is to cope with circumstances that we haven't seen before or we haven't specifically taught it about. And then at the bottom of that, I think there's also algorithm intelligence, which we see quite a lot, cunningly chosen to have the same letters as AI. And that's all about where we've actually got very, very powerful algorithms whose combined effect is that of achieving intelligence, even if it wasn't itself designed to. And then my bottom level of the stack here is what I call fake AI. Up until about a year ago, of course, this was what an awful lot of AI was. Lots of things were touted to be AI, but in fact weren't. That has diminished, though there's an interesting effect. Previously, it used to be that once we knew how to do something with artificial intelligence, it was no longer AI. So chess was for many years the example that everyone worked on, trying to make good chess programs at the forefront of AI. But now that that's, as it were, more or less cracked, people think, well, we know how that rabbit comes out of the hat, so it's not really AI anymore. But with these large language models, something interesting has happened in the kind of public psyche. They are now taken to actually still be AI, even though they are actually themselves now known how they work. So they have broken that particular path. But there's a question, I think, that really pertains to all of this, which has been touched on before. Where are these generative large language models? Are they at the artificial intelligence level, or are they actually heading up towards the machine sentience level? Now, for my money, I think they're still at level 2. But the big question is, are they actually going up higher than that? And to look at that, we need to understand a little bit more about the knowledge that's occurring down deeper. So let's look at some of the language representations and the knowledge representation. So I've categorized it into 3. And this is only within the scope of these discussions. Of course, there's lots of other representations in AI. So we've got implicit language models, explicit, and basically knowledge-based models. So what I mean by that is what representation have we got for language? So these implicit language models, the neural nets and n-grams and so forth, like we're talking about today, that's very implicit. Then you've got explicit language models where someone has modeled the grammar, modeled how the language actually works. And I won't comment on the knowledge models at the moment very much. So then we get down to the next level. What is about the knowledge and the reasoning? Well, these implicit models are very interesting because the knowledge is, as it were, spread thin throughout all of the parameters. And it's not something you could actually, as it were, open the lid and go, oh, here we go. Here's the representation of what aeroplanes are or mean. And explicit language models have the same characteristic. But if you have a model that's actually based about how the world works, so with graphs or rules or semantic nets or something like that, then you have got an explicit language, an explicit knowledge model upon which reasoning can be done. And I believe there may be a seminar coming up on those sorts of topics in the near future. If you build a system along those lines, you're then going to be, any language you're going to be doing, you're going to have a distinct separate phase for synthesizing that language rather than it being intrinsic to the original system. And then finally, of course, we get to the question of how we actually acquire knowledge. So these implicit language models are obviously, they're inducted by, as we've seen, huge numbers of documents. And of course, for that reason, they may themselves be very energy expensive. Explicit language models, knowledge bases and so forth tend to be obviously handcrafted and therefore staff intensive. But of course, they are actually validated. It's not going to come up with something dreadful that you hadn't thought of. Incidentally, many of the implicit language models, of course, also then have a very human component in setting up policies and so forth as to what they're going to say. So they may not be quite as light on the human front as we might have hoped. And then finally, if you've got explicit models, you've got to go through the language, you've got to parse it, which is actually very hard. And then you've got to solve some of the other hard problems in AI, such as entity resolution. So one document talks about John Smith. Is that the same John Smith as the other document is discussing, or not? That's often very hard. So I would say that the large language models that we're talking about now are very much in that top left corner, the language representation, which is implicit. What I'm going to talk about in a bit, if I'm going to show a little demo of, is something that sits down here more towards the right. So I'm going to talk about marketing copy generation, so writing marketing materials. And that's what I shall also be demonstrating. So this is a system that the company I work for is creating. It's called Casteleiro. We regard it as augmented intelligence, so it's explicitly about writing marketing copy. And we call it augmented because very much we have human beings in the... I think we've got more than one of us on this call. So it's highly persuasive. It's absolutely aware of human psychology. It's aware of personalities, and it's aware of different persuasion techniques. So I imagine many people at this point are thinking, "Oh, golly, I'm not sure I like the sound of that," in the sense that it's actually thinking about persuading people. So this immediately gives rise to the ethical dimension that I think we will be thinking about much later on. So how we have to cope with this ourselves is we have to be very careful to use persuasion techniques, not to manipulate. We don't make it available for advertising social ills, gambling or smoking and things like that. And then finally, we have to make sure it's explainable so that it can actually say why text was chosen. It's got some sort of reasoning in there, and it can explain that to you. So what I'm going to do now is give a little demo of this tool actually running. So I think at that point, that's the end of this presentation. I'm happy to take questions and hand it back to the chairman.
Thank you very much, Andrew. That's great and very brave to do a live demo. So if anybody's got any questions, it'd be helpful to pop them in the chat. So while you're thinking about that, maybe I could go back to an earlier question from Olu, which either Andrew or Mercedes can answer if you like, which was would the Turing test be enhanced if large language model applications could answer with a degree of certainty? I don't know if either of you would like to think about that or respond to that.
I'm not sure it would be particularly enhanced by a degree of certainty.
Okay,
that would be my view.
I mean, it's the whole thing about modeling uncertainty has a long history in AI. I'm not sure if with things like Bayesian models and so forth. I really don't know if they have much of a role in large language models. To be honest, it's outside of my experience. Okay, no problem. Oh, sorry, was Mercedes going to speak? Yeah.
Yes, I may say that sometimes the output of a large language model, it could be, I mean, you can use it in combination with some other things. Like sometimes people like to put afterwards logistic regression or some other things. I mean, there is nothing to stop you in order to combine this technology with other things. In fact, if I may say, the purpose of the talk I'm going to give later is in order to allow some of you, if you wanted to experiment, to combine this with some other things. Maybe I'm interpreting this as trustworthy, like how trustworthy is my answer? Like when somebody says, is cough a clinical presentation symptom for COVID? If there is a percentage, like I think it might be on this percentage. Is this what you mean? But this perhaps relate also to the trustworthiness. How trustworthy is the reply? Instead of being assertive, like is 100% true, trying to establish, some some boundaries? It's a very interesting question. And as I say, some people are combining things. So thanks very much for the question, but perhaps it doesn't have a straight answer. You also have to think that Alan Turing was in the 50s and he was dreaming that perhaps in 2000, there will be already algorithms and machines able to pass his test. And he will say maybe 73 or 75% of the algorithms will pass his test. So incidentally enough, he was putting even a percentage. So thank you.
Great, thanks very much.
May I add to that? I'm not sure the Turing test is any more sufficient test for intelligence, because if you could build a system that sufficiently emulated a human being, it wouldn't follow that it actually was intelligent, because as human beings, when we say artificial intelligence, we actually mean more than intelligence, don't we? We mean all those other things like sentience and ethics and sense of humor and knowledge of right and wrong and so on and so forth. So I think to me, the Turing test has done its thing, but it needs to go further and deeper. We kind of need an enhanced Turing test.
Indeed, but it's impressive that it's that we're still talking about it 73 years after it was proposed. Olu did actually get back and say that yes, trustworthiness is indeed what he meant to infer in his question, which was and that was an aspect that was picked up there by Mercedes. A few questions have popped up while we've been talking. So Mike wanted to ask Andrew, did you use the OCEAN, that's uppercase OCEAN, personality model?
A very simple answer to that, yes.
Okay, thank you very much. Nick Oatridge says, does not in an LLM the discriminator have a confidence threshold? Could that be baked into the certainty of the response? I think we're picking up the earlier discussion now that Olu mentioned. Well, maybe we've probably done the certainty thing, so let's move on. John, I think this is a comment rather than a question, says the Turing test is arguably a test of gullibility, not intelligence. Yes, Rick, maybe Rick better explain his comments. So what's your ChatGPT for coffee for commuters?
I was just trying to do a quick comparison of what the model that Andrew presented to us with, a quick interrogation of ChatGPT to see what alternatives it gave us.
I see. Oh, great. Thank you very much for that.
I'm not a marketing person, so I did ask it for someone who was, he started off conscientious, he interpreted as being sustainability rather than a conscientious personality type. But having corrected for that, I'm not saying they're any better or any worse, but I suppose the question is whether ChatGPT does undermine some of these other approaches to these problems.
Can I pick that up? Does it undermine? Well, it's a different approach, isn't it? So what we were seeking to do is to be able to have actually quite a lot of subtle control over quite a lot of different elements there, the exact personality that was going to be used, the persuasion techniques that were available, and so on and so forth. Not only that, we wanted to be able to control exactly what type of output could be generated. We want to be absolutely sure that nothing inappropriate could be said, and we also wanted then to get it to choose, which I didn't really demonstrate, but when we have a larger bank of images than just the very small one I've got there, it's actually also able to look at the images to some degree and go, right, what image works alongside the text that I've just chosen to create. Later on, we'll be talking about the implications of the different sorts of data that you might use for training. And that's another set of reasons why you would want to use something that gives you this level of control. But I think with all AI technologies, generally speaking, they are good for some things and not good for others. So it doesn't follow that you can do absolutely everything with ChatGPT. People do seem to try to do absolutely everything with it, don't they?
Okay, thanks, Andrew. I think that's a good point at which to move on. We're on schedule. So I'm going to hand back now to Mercedes. Thank you very much, Andrew, for your first slot there. And Mercedes is going to now tell us more about where to find large language models, and particularly talking about Python libraries and code. So over to you again, Mercedes, please.
Yes, thank you so much to you and to Andrew. And of course, to all of you for very interesting questions. So let me share my screen.
Yeah, that's good. Thank you.
Okay, thank you very much. 2 key points before we even start. My intent and purpose is trying to give you a flavor or different things that you can do programmatically. I also make sure that everything that you see here, you can do yourselves. Because one of the things that is very, very frustrating is there is a lot of code here and there. And when you try to execute or to replicate results, sometimes it's very disappointed because there is some missing library or some missing files or some missing something. So whatever I'm going to show you, you should be able to do it yourselves. But the compromise is whatever I'm going to show you perhaps is a very basic level. However, through this event and through this community, let's try to take this as a primary contact. And some of you, if you wanted to pursue or to know more things about it, by all means, let us know. So let's go about it. And as I say, try not to gather everything, but more or less give a flavor, get a sense of programmatically what you can do easily, just with few lines of code. So the first thing is libraries, where I can find OpenAI GPT or some other models. So this is one of the key points, which is Hugging Face, Python library, and you will have available different models. You can see, unsurprisingly, that OpenAI GPT was downloaded almost 1 million times just last month. Another information point is there are many, many more models. It's not only OpenAI ChatGPT. So one of them is BERT, as I tried to present you before. And you can see also that GPT-2 is farther down. So we are going to experiment with these 2 in the session of today. So let's come back for a moment about Megatron Turing. So one of the things very, very interesting this minute is people are trying to investigate if we have very strong pre-trained models. Can you see that they are pre-trained with a lot of data sets already? Maybe it's not so much necessary to do the fine-tuning, to train these models for a specific task, which was one of the questions you asked before, and is one of the open questions. We still don't know. We need to experiment. So just a few years ago, a couple of years ago, this field is moving very fast. People were doing pre-training. So in order to do the pre-training, perhaps you need a very powerful computer capabilities, because in order to pre-train these models, sometimes you use the whole Wikipedia or you use PubMed. PubMed has 35 million papers as of today. So not everybody was able to pre-train these models. And of course, because there is a lot of medical data, some people started to question that we can have general domain language models like BERT and Roberta, but if you have domains like the biomedical domain that has a lot of data and corpora, maybe we can pre-train models specifically using the data for this domain. So this is more or less today a curiosity perhaps, but just to keep in mind that there are general domain language models that then you can fine-tune for very specific tasks, or some people were even pre-training for specific domains using a specific corpora. Now, for all the examples that I'm going to give you, all the different pieces of code in order to do many different things, I'm going to use Google Colab. And the only requirement is that you have a Gmail account. I'm hoping that this requirement is a not very strong requirement. And as soon as you have a Google account, you'll be able to replicate exactly what I'm proposing. So one of the very simple experiments is you select a model like BERT model, and you give it a sequence of words, and you want it to guess the masked word. So for example, Rome is the of Italy. So what is the missing word? What is the masked word? So if you execute this code at the very end, I mean, after installing and loading and doing all the things automatically, you can see at the very, very end that the answer appeared. Just for convenience, I'm going to put it more clear here. So with a score of 0.99, you will have the word capital. With a score of 0.0069, the bottom one, you will have center. And many of you may agree that Rome is the capital of Italy. So it looks like it's working in the sense that the word with the highest score seems to be the appropriate one. Perhaps you can see here the scores, and some of you is seeing explicitly one of the things that we were mentioned before, the kind of confidence. Can you give me a percentage, a score, a number, in order to know if capital is better word than center for the mask task? If you wanted to experiment yourself, you can change it. And for example, you can say the man worked as a, and try to see what it come up, or the woman worked as a, and see what it comes up. Some of you have heard that there is bias or some prejudice. There is ongoing discussions. I pick up these two examples on purpose, because if you have a look to the different jobs suggested for men and female, maybe you notice that there is some bias or something is happening here, that perhaps is because of the data that was available when these models were pre-trained. Now, if you wanted to have a look to the insights, like maybe you heard that in the end it's about matrix and tensors and this real number matrix. So with this piece of code, my only intent is to print out the outputs so you can see specifically a little bit of this real numbers matrix. Now, one of the typical examples is the prompting, like, hello, I'm a language model, and then we ask for alternatives in order to complete the sentence. So I use the model that I was showing you at the beginning, the OpenAI GPT. Again, you can see there is very few lines of code. Normally, I just commented the code. So typically you install some libraries, then you load some libraries, and then you have 2 or 3 lines of code in order to indicate the model, in order to indicate the task. So in this case, we're asking for 5 sentences, which is what you can see there. Of course, this is this OpenAI GPT, but maybe you're curious and you say, what about trying another GPT model? Maybe it could do better or worse. I'm not sure. I just wanted to experiment. Of course, you can do that. I'm trying to give you this very simplistic experiment, which is what we saw before with Eliza, the famous sentence, I am unhappy. And try to see these 2 models, the OpenAI GPT and GPT-2, what kind of replies, what kind of sentences they provide. And maybe just reading quickly the kind of answers, maybe you will get the sense that perhaps GPT-2 seems to do a bit better, like the kind of completing or the kind of replies for this prompting seems to be better articulated, perhaps. But again, This is something that in order to do properly, we have to establish some metrics and we have to establish some criteria in order to say which reply is better. But I just giving you the chance in order that you can, with few lines of code, you can experiment and you can see for yourselves what kind of replies you can get. Now, if you go to OpenAI and you go to the examples that they provide, and you are a bit curious and wanted to know a bit more, one of the things that they gave you is the settings. And in the settings, if you read carefully, you will have something called engine. And this is the kind of information we need if we wanted to do this programmatically. So unfortunately, GPT-3 is not a model that is available through Hugging Face. So normally what you have to do is you go to OpenAI, you register, so you will have a login and a password, and they gave you this API key. Once you have this API key, that as you know, this is a super lengthy string, you can go back to Google Colab, just write these very few lines of code, and the question that we were seeing before, like, do you have consciousness? So we asked this question to this specific model which is the text DaVinci 003. And you can see that it replies similarly to what we saw before with ChatGPT, but brief, because it just says, no, I do not have consciousness. I also leave on purpose what is the output, because I guess that some of you might be interested in combining this with some other things that perhaps you are doing or investigating at the moment. So this is a fair account of the code and the kind of output that you have that you can combine with some other things. Now, if we come back to BERT, as I say, a few years ago, BERT was saying that it was the state of the art for questioning answering, and you just have to pass BERT, the question and a passage. So again, I'm going to give you a very few lines of code in order to do that. So as you can see here, first we do the pip in order to install this library, then we load certain libraries, we load the model, in this case is BERT base. The question is, how many people live in London? And then for passage, we have a title and a test. And as you can see at the very end, in this case, how similarly or how good is this answer for this question, you can see that perhaps it's not very good, because you can see that it's 0.6778, which again, it goes back a little bit to the previous question about having a scores and measures in order to know how good is the answer. Another thing that you can do is Roberta, which was general purpose large language model. It was fine-tuned specifically for sentiment analysis. Sentiment analysis, for example, if you watch a movie, you can say if it is a good one or a bad one. So the sentiment is trying to express this positive, negative. So if you wanted to use Roberta already fine-tuned for sentiment analysis, again, it's very few lines of code. You do again the pip in order to install transformers, you load the library, and then it's basically 3 lines of code. And as you can see at the very end, giving 2 sentences, I love you and I hate you. So the first one is positive with a score 0.99, and the other one, I hate you, is negative with a score 0.99. So again, you can see the scores working. One of the things that I'm going to do next, and again, I do apologize because this is full immersion and you will have probably a lot of questions. So perhaps I have to tell you beforehand, no, what I'm going to show you perhaps is not optimized. Perhaps what I'm going to show you, you can do better just with a bit of practice. There is also code in order to try to guess or to figure out what will be the best hyperparameters configuration, depending on your data and so on and so forth. But for the brief of just giving you a taste of how you can fine-tune BERT for a specific task, as it could be sentiment analysis, I'm going to walk you through to a sequence of steps. And probably if you want to fine-tune BERT for some other task, you will have to follow a similar sequence of steps. So the first step is install and load libraries, which is what we saw before, but perhaps in this case, you will have to install more libraries and perhaps you need to load more libraries. The second step is the data set. So again, with the aim that whatever you see here today, you will be able to replicate and it's going to work, I just select a data set that is available online. You can download it, it's relatively small, just have 2,000 rows. And of course, a typical thing that we do is to split this into the training data set and then the data set for evaluation. So I also included here a few lines with the print, so you will know more exactly what this code is doing. So in the output, in the print, you can see that in this case, this data set, you will have some text and you will have some labels. So you can see row 0, 1, 2, 3, and 4. And you also can see that this data set is basically 2,000 rows. And the way that we split it is we have 1,800 rows for the training and 200 for the evaluation. The third step typically is prepare the data set. So you have to prepare the data set for BERT. But again, Huge Face Library is offering you already tokenizers, so this task can be done effectively just with few lines of code. So as you can see here, the first lines of code is related to prepare the data set for BERT, and then divide the data set into the training and evaluation. So again, with very few lines of code, you have your data set ready. The warning or the be careful is depending on the data set and the task that you may do, perhaps this step, the code, it needs to be changed. It needs to be adapted. So be aware of that. Now for step 4, and as I say before, it's definitely not optimized. Probably you can find a better scheduler. However, or another configuration for Adam in order to work. But the purpose is trying to give you a flavor. So you know that in this step 4, you need to select the BERT model and you need to create a scheduler. So in this case, for example, I'm just saying that the number of epochs is 3, but maybe you wanted to change that or some of the other things in order to do better. This is just like the essence that then you can modify and refine and do better, of course.
Mercedes, I'm sorry to interrupt, but I need to ask you to wrap up, please.
Okay, thank you. So this is the step 5, which is the fine-tuning of the model. That it will typically show some progress bar, and then the evaluation step, which will show the performance, which in this case, the accuracy was 91.50%. And for some of you interested, I just prepared some slides in order to know more about available data sets and even the leaderboard about these different, who is doing better with these data sets. Then a little of acknowledgement about the people who helped me to prepare this talk and is also working with me in investigating fine-tuning of large language models. And I'm ready for your questions. So thank you.
Thank you very much, Mercedes. We haven't actually got any questions come through just yet, although there have been a couple of people asking about where and when the recording will be made available. I think Max is going to manage that, but subject to the speaker's agreement, we'll be putting it on the BCS YouTube channel, and Max will place a link to that from the SGAI webpage, which you must have all found in order to come here today. And there you go. Max has just helpfully written that in the chat. So I think maybe we'll just move straight on to the final presentation, and there should still be a bit of time at the end of that. So thank you very much, Mercedes, for your second presentation there. The fourth slot now is back to Andrew Lee, who's going to talk about challenges of large language models, ethics and beyond. Over to you, Andrew.
Thank you. So I hope everyone can see me, and they can probably see my screen as I try and find where we are back on the presentation. So can you see the presentation, please, Chairman?
Yeah, that's all working. Thank you.
Okay, marvelous. Right, so that's where we were. So a slight change of gear now, as I think we start to look at kind of the ethics of this sort of stuff. Hence the title, Ethical Risks. What I'm going to do really is talk about those, but my argument now isn't going to be so much an argument from the technology as an argument from the data, because if we're training systems, obviously we're training them regardless of how they actually work, regardless of the clockwork that we're using on that data, and that data is what gives rise to some of the risks that you see, some of the almost ethical risks. So there's three classes, obviously enough. There's the public data where we train off the internet. There's the private, the corporate data, if you're a large organization seeking to use these sorts of technologies, or even a small one, I suppose. And then, of course, there's hybrid, which is to say data that you could find on the internet and you would find corporately and you've used together. So what I'm going to do now is explore those three categories and look at the sort of risks that they cause. So firstly, let's look at hybrid data. So this is both internal and external. So the first one, obviously enough, is for a consultancy, for example, is originality. If you've got customers who are paying you to write things and you use a large chat model to generate it, that's not what they expected. That's not what they wanted to pay for. So that could go down very badly indeed. Secondly, there's this whole business of explainability. It's better understood really in the context of AI that's making decisions, such as should we give a mortgage to this applicant or not. It's obvious that you want to be able to explain why that was the case. But the same thing applies here. Just as with my earlier demonstration, it'd be good to say why the system chose that particular text. That might be something you want to know or need to know. And alongside that, you have transparency. So the reasoning whereby this particular piece of content was found or was used in the answer. Some systems, of course, can go quite a long way to doing that, especially if you can constrain them to use particular bits of data in their answer. But then we get to the big one, the omission. The system may not know what it might be missing. I think this particularly applies to the large language models because they, as it were, they literally only know everything that you've taught them. So there's no ontology behind the system that's telling it, actually, you know what, there may be other bits that you should, other slots that you should be filling in. So it doesn't necessarily know that it hasn't got those slots to fill in. I actually wonder if any of these large systems ever give the answer of, I don't know. There's a question for everyone else. Bias. So this was discussed a bit. Mercedes raised this earlier on, the whole question of bias in data sets. Of course, the question of bias in AI isn't just related to large language models, but it's particularly interesting. Often, of course, what we're complaining about actually is lack of bias. The data, the AI, its duty is to reflect the data it was trained on. So it will simply reflect back whatever bias exists in that data. Or it may be that bias doesn't exist in that data, but you, for your own ethical or social engineering purposes, think there ought to be a bias there, or that neutral actually isn't neutral, and this is where society should be, and this is where it should end up. So bias is an issue. I wouldn't say it's an issue of the technology. I would say it's an issue of the data or an issue of the expectation. And then error. And this arises really from two sources, of course. Firstly, from the underlying reasoning that may be going on in the system, which again is often not explicit, but also, of course, from the underlying data. If you train a system on data that's incorrect, then of course it's going to come up with incorrect answers, especially when there are implicit assumptions. But that can be quite big. We saw earlier the questions as to the accuracy, where you're asking a large language model about questions such as medical questions. How often is it actually going to be correct, or worse, I guess almost worse yet, miss things out? Okay, for some reason that has frozen. Okay, and timeliness. At the moment, many systems, of course, take a great deal of time to train, and therefore they are trained at particular epochs, particular years, and they would therefore go out of date. That may matter to you. So moving on from hybrid to what I've described as the wild west of the internet. And this really is, the first risk is quite a big one, third-party privacy. So the classical example of this, I think, is the Enron dataset. This was released by the United States. It was a whole collection of emails relating to the collapse of the Enron corporation, and it was made available for people to train language models and do research into language understanding, AI, and so forth. But it contained quite a lot of personal data. Now, it turns out that is now something you can't use. So just because something has been disclosed on the internet doesn't mean that your subsequent onward disclosure of it is lawful. So third-party privacy is easily violated by a system that hoovers everything up and then regurgitates it. However accurately it might be that it's done that. Quite a big risk there. So the next one is related to that. That's IPR infringement. Again, the system doesn't necessarily know where it is it's found out this information. And worse yet, of course, it may have found out bits of information around different places and may have literally no knowledge that it's infringing IPR. Plagiarism, of course, is a very familiar thing for anything that's being derived from the internet. And it's harder yet, where different elements are being put together. And then defamation. So this is very interesting. I had a specific example of this with one of the large systems. I asked it to describe me, and it alluded to an event that actually wasn't associated with me, but it mistakenly thought it was. And frankly, had that been published by somebody, I would certainly be regarding that as defamation. Now, I'm not a lawyer, but I would pretty much bet that the liability remains with whoever publishes stuff. You can't really go, I had an AI generate it for me. It used data off the internet. It's not my fault if it's defamed somebody. I'm sure that wouldn't wash, or at least in a non-lawyerly way, I think it wouldn't wash. So similarly, that's a nice echo that's coming up. Is everyone else getting an echo? Oh, it's gone now. So laws and taboos on speech. As we know, in some countries, blasphemy is illegal. In this country, of course, you have got quite a lot of constraints on what people think is acceptable to say, and you may have no control on what a system generates. Similarly, you might wind up with accidental innuendo or obscenity being generated that you had no intention. This last one I think is very interesting, which what I've called here is bit rot. Now these large models are around, people are starting to use them. The output of the large models are themselves going to be on the internet. If people now train the next generation of models off the output of the previous generation, you've got a cyclic effect going on. This almost certainly means that errors will compound up. So that's something to watch out for. So that's the wild west of the internet. And if we now look at the corporate data, by which I mean training your language model on your own data, the first thing, of course, is second-party data, basically customer data. So if you let it rip on all of your data, you might wind up, if you just let this stuff out, revealing information about your customers, which would be truly dreadful. And of course, you may also leak data and IPR of your own confidential data may get out there if you train it on everything you've got. Okay, and then you can also have a combinational problem if you're combining this with other systems. The complexity can go up through the roof, which can cause errors of its own. And then finally here, we've got the whole issue of compliance, GDPR and so on and so forth. How are you going to ensure that your use of this, your output is compliant with those regulations that you've got to comply with? So, okay, that's a pretty bleak picture. What are the mitigations to deal with these things? So obviously you've got to be aware of what you're dealing with, of the nature of the beast, as it were, of its strengths and its weaknesses. The obvious method of mitigating is to look at the data to make sure that you're only training it on the appropriate data. This may, of course, mean that you can't just use the Wild West data from the internet, and therefore you've got to make sure it's trained only on your own curated data, which again may be an advantage of systems that aren't so much automatically trained. And then there may be technical measures you can put in place to make sure that the wrong data doesn't leak, things that are, as it were, checking as it goes. So on to an entertaining bit, which is always good fun. I'm going to use my 100% accurate crystal ball to give some predictions and some of the implications as to how I think some of this stuff is going. So here we go. So the very first one, and I think we're seeing this happening now, is that these large language models will become incremental, reducing latency and training costs. In other words, what's going to happen is they will be able to be up to date. They'll just be able to update yesterday's versions with today's data, which also then will hopefully mean that they use less power consumption because they're just doing less training. So that seems to me a good thing. The next thing is, let's suppose this implicit knowledge representation really is a route to artificial intelligence. Now, I think that's a big if, because I don't know that it automatically does. It seems to me a large language model is itself deducing the data representation that it's using, as opposed to it being explicit in some sort of network or ontology. But nonetheless, let's suppose that is the route through. Then we have to ask ourselves, will we trust them? Will we trust those models? If they've become properly intelligent, properly sentient, they will then have motivations of their own. So how do we know that they're even going to tell us the truth? And equally, how will they trust us to tell them the truth? And this is perhaps the biggie in terms of our society at the moment. I think it's very likely that this sort of technology will displace many professionals who might have thought they were immune. So solicitors and programmers, I can absolutely imagine going and talking to a virtual solicitor that's been trained up in all of British law and you know, paying £10 rather than hundreds or thousands of pounds for advice. And I would do that. I'm sure many other people would do that. Wouldn't displace all solicitors, but it might well displace quite a lot of solicitors. Similarly, programmers, if this sort of AI can generate good code, well, it's going to start to be used. And of course, it's not the only technique for generating good code. Some of the things I mentioned very on in the introduction is different ways of automatically generating code that will also come along. So it's not the only threat in this regard. So what are the implications to this as a society? So the big question is, how does society share the benefit from this? Do just a few get richer? Is there a technical elite? Does the state grow ever bigger and simply mop up with inefficiency the benefits? Or is there a way in which we can all wind up working less? Obviously, this is also related to other issues like robotics and so forth. But it does seem to me this is the big challenge of AI. How do we make it that as this stuff does more and more, that everyone benefits rather than that benefit being concentrated in the hands of a few? So I'm on to my last slide now, and this is my final thought really, which I'll end with. To me, explainability is the AI equivalence to and of accountability. And for me, this is something I always want to see AI able to do. So there we go. That's the end of my presentation. Back to the chair. Thank you very much.
Thank you very much indeed, Andrew. So your presentation there's triggered quite a few questions, although if I may, I'll go back to one that Ying posted just before Andrew started. So I think presumably aimed at Mercedes, which is, can you fine-tune GPT for entity extraction? And if you could make your answer quite brief, we've got quite a few questions to get through, please.
Yes, it was done. It can be done. Yes.
Perfect. That is indeed brief. Thank you very much. Sally's posted a question which she might need to enlarge upon because I'm not sure I entirely understand it. She says plagiarism, the ChatGPT rise and shine example. I don't know if Andrew knows what the rise and shine example means.
No, I don't.
No. Are you able to enlarge upon that, Sally?
Yes, can you hear me?
Yes.
You can hear me, thank you. No, I was thinking of a famous advertising slogan with the egg marketing board, Rise and Shine it started with, and I thought, that's immediately what I thought of when that came up in the chat.
I see. Yeah, sure. Okay, got you. So yes, it came up. So it's someone else's historic slogan, and yet it came up by ChatGPT in response to the coffee experiment. Thank you very much.
Yes, I mean, not specifically for marketing. That was just somebody having a go with ChatGPT.
Yeah,
but
indeed.
I thought it was great that it came up in one of the presentations as well.
Thank you. Thank you very much. Sri Priya says, isn't explainability domain specific if it is to be understood? The medical domain being a good example. Would Andrew or
I'll tackle that. Yes, absolutely. I think it is domain specific. The sort of explanations that you would expect on marketing content would be very, very different from the sorts of explanations you would expect in a medical context. Yeah, absolutely.
And thank you. And Nicholas Walton says, what about the danger of connections being made between disparate facts that reveal what should not be revealed?
Mm-hmm. So that is something that could happen, couldn't it? If the system scooped up all of the data off the internet and linked things together and deduced things that, personal data, for example, it might deduce where someone lived and then reveal it. Yeah, that is a thing that could happen and would need to be taken care of. And that's why I personally think there's quite a risk, as we've just been through, with harvesting all of the internet data and then using it.
Okay, thank you. Olu poses a different question. How about model attacks and cybersecurity? And will large-scale use of models lead to similar solutions and boring robotic output in some sectors? I think that sounds like two slightly different questions, actually. I don't know if you can. Well, I think for me, the second question is a clearer question. Will large-scale use of models lead to similar solutions and boring robotic output?
I'm sure it will. Yeah, I think in many cases it will. I think also, though, the use of the right systems in the right place actually will also yield sometimes more interesting output. It's not just AI systems that can produce boring output, is it? I think some people can manage too. I probably did earlier.
Not at all. So, Olu, I don't know if you're able to enlarge upon your first point, your first question. How about model attacks and cybersecurity? What you actually meant there?
Yeah, sure. It was just as Andrew was listing some of the challenges and issues going forwards. Model attacks, I was thinking, is also a challenge, as is cybersecurity. And of course, we've all recently heard about some of the attacks on the OpenAI models.
Thank you. I don't know if that needs a response, but thank you for clarifying. Mike Lloyd asks, what's XAI, explainable AI models, work with large language models? I don't know if either of you would like to take that, Andrew or Mercedes.
I can comment on other sorts of language models, and that's one of the reasons I use other language models, because of that explainability nature. It's just back to the core of neural nets, artificial neural nets. Just how explainable are they? They can be a bit black box. I know some people are working on techniques to make them explainable. I think wherever you've got that neural net, you do have that issue of, is it a best to grey box? And it doesn't just affect large language models, does it? If you have self-driving cars or something and you're doing image recognition, the system may not be able to say why it didn't spot that cat running across the road. So I think it's a general issue. Mercedes, have you got anything on this?
Yes, indeed, is part of the research I'm doing, it relates to that one. So one of the ideas is slightly different to Andrew's point of view. You can think of explainability as that the user understand the reply. So perhaps in this context, when you try to do an explainability is try to justify the reply, like, for example, providing some provenance or some evidence. In the case of this medical reply, for example, is cough, a clinical presentation symptoms for COVID. The model leverage a reply, but it's not saying according to which scientific evidence this reply is being based. If this additional information will be provided, it's a way of getting more trust from the user, like in order to make my reply, I'm using these information sources. Because as Andrew mentioned, sometimes these models are trained with certain data, but perhaps we don't even know exactly, where this answer is coming from. So trying to retrace and trying to provide an information source, some provenance, some evidence can be helpful. But this is an area of research, it's an area of work. So thanks for your question. It's a very interesting one. And I guess Andrew also, have this kind of, more practical point of view.
Thank you both. Look, it is now 7:30. We reached the end of our allocated time. A couple more comments rather than questions have popped up. Rick Payne says, regarding domain specificity of explainability, perhaps some elements could be distilled into general principles. And Mike Lloyd said, for example, explainable AI model LIME. And we've had some nice comments as well to thank everybody. So it's my job to thank everybody for joining us today. I noticed we were at 108 at one point, which is great attendance. Thank you so much to our excellent speakers today, Mercedes and Andrew. And I know Max wouldn't forgive me if I didn't do the plug for the next online event. And I'm going to share my screen, which is actually just the website, which shows the UK Symposium on Knowledge Discovery and Data Mining, otherwise known as KDD, UK KDD. So that's on the 14th of June. As you can see there, Mercedes will be starring again, this time alongside Professor Stefan Schultz. Mercedes will be talking about graph databases, including knowledge graphs. Professor Schultz hasn't yet revealed his hand, but it will be in the general topic of knowledge discovery and data mining. And right at the bottom there, you can see that the website for the specialist group on AI, so that's BCS-SGAI.org. And indeed, you'll find that page links to all sorts of fascinating stuff about the group and its events, and we are subject to permissions and everything. We will put the link to tonight's recording there as well. Has that covered everything, Max?
Yes. Well, can I just jump in here? And I think the only thing we haven't done is thank you for excellent job of chairing the event. And can I also thank again Mercedes and Andrew? I think this is a really good start to a new series. And if you in the audience have enjoyed it, then come along to the next one on June the 14th. Be in the same place, wherever you want to be, via Zoom. So at this point, I'll stop the recording.
Okay. Thank you very much, Max.